So my pitch is that web fragments, unlike module federation, actually works and scales. So that's the pitch. But I don't want to sound. I don't want to. I know. JavaScript drama. The problem is that we are taking very radically different approach. Module federation is all about how do you scale your application by creating these leaf nodes within the application graph that can still share state, share JavaScript, share modules within the overall federation. That's why it's called module federation, because you have modules, JavaScript modules that know how to collaborate and reuse each other and still be somewhat independent and in the leaves. But fragments take the very opposite approach. And that's on purpose. The reason why we take a very different approach is that one thing that we realized is that no matter if it's module federation or, there have been other approaches to scaling applications. And ultimately, where these approaches fall apart is that you end up coupling fates of individual teams in some point in the application lifecycle development.
One of the promises of any microarchitecture that you have independence, team independence, you have tech independence, you have decisions, architectural decisions independence. And we have failed until now to deliver on that promise, right? And what we're trying to do is, and we like to think about this, we recently came up with this idea, actually. What we're building is kind of like Docker, but on the browser. Right? So we are fully encapsulating a context of execution for JavaScript. And at the same time, we're encapsulating the DOM, but in a way that it still is one single document. Mm-hmm. And we're going to explain you a little bit how we do this, but we still deliver on that promise of full independence and not sharing the fate between teams and between applications to some extent.
So what web fragments do with this technology we call reframing is you still get the JavaScript context of the iframe, but we don't use the DOM of the iframe for any rendering. Instead, what we do is we use the main document to render the UI of the application running in the iframe. I'll say it again. So application runs in the iframe, but any kind of DOM operations don't happen in the iframe. They happen in the main document. Now, if you just did this without any other precautions, you would have other problem with collisions, which is your IDs, DOM IDs could collide, your CSS can collide, and there are other things that could collide. So we use shadow DOM to create a boundary, isolation boundary for each fragment. So each fragment uses iframes to isolate JavaScript and uses shadow DOM to isolate the DOM of this fragment. And this gives us a full encapsulation both on the visual side and CSS side and DOM side, as well as on the JavaScript side. How is this possible? I'm happy to go into the details if you want. We call it reframing. It's a little bit of magic that we develop. But what is server-side rendering good for if the shell of the application is client-side rendered? Because that would then typically mean that you need to bootstrap the client-side rendered application. And once you build out enough of the DOM, enough of the UI, that's when you can do server-side rendering to inline a part of the UI. And that defeats the purpose of server-side rendering, because the whole reason why we want to do server-side rendering is so that we don't have this big pause between when the user initiates the navigation and when something shows up on the screen. We want the initial rendering to be as fast as possible. We want to show something very quickly, and not just show, and we actually want to make it interactive, as Natalia mentioned. And this is why we developed a feature within Web Fragments we call piercing, fragment piercings. And the reason why we call it piercing is because if you think about it, we need to be able to pierce server-side rendered content into a client-side rendered content in a way that allows you to show the server-side rendered content before the client-side rendered content even exists, which is interesting because, like, how do you render into something that doesn't exist yet? But that's what piercing does. It's another part of magic that we developed for Web Fragments.
Today on Señors at Scale, we're joined by two amazing guests who've been shaping the way we build for the web, Natalia Venditto and Igor Minar. Natalia is a principal product manager at Microsoft, leading developer experience for JavaScript. And Igor is a senior director of engineering at Cloudflare and co-creator of Angular. And together, they've been working on WebFragments, a radical new approach to micro-frontends. Welcome, guys. Thank you for joining me.
Thank you. Good
Thanks
to
for
be
having us,
here.
Dan.
So tell me, how did this came together? How did you meet? How did you think that we need something better than what's on the market right now?
Well, I think separately we have been researching and building micro-frontends for many years. And I think I was a guest at a podcast with John Papa at some point, and Igor heard that podcast. Was that correct, Igor?
That sounds about right. I think so. Yeah. I think there was a, what is it, Code Rush, Dev Rush
Yes, WebRush.
episode, WebRush episode on micro-frontends. I was like, oh, somebody's thinking about the same problem space.
Exactly. And yeah, and we got in touch and we started working together, sometimes just sharing our opinions on the subject. And then it ended up being that Igor was building this framework and he invited me to be part of it. And because it's open source, yeah, I was very excited and thrilled.
Yeah.
That's pretty cool.
Exactly. Like, this space is quite small. There's not too many people thinking about micro-frontends. There are people that are implementing and using micro-frontends, but there are very few people that are actually thinking of the actual architecture and how to build these applications, what is the tooling we need, what is the infrastructure pieces that we need, other libraries that can make it easier. There's literally a handful of people in the world thinking about the space.
So what makes it different actually than Module Federation, for example? The
Wow,
first
you're
question
getting
that I
right to
have
the
to pinpoint, I've never used Module Federation, so I know the high level concept that it does, but I've never used it myself. So I'm curious what's WebFragments doing.
So like, in order to get attention, you need to stir controversy. So my pitch is that WebFragments, unlike Module Federation, actually works and scales. So that's the pitch. But I don't want to sound. I don't want to. I know, JavaScript drama. No, the problem is that we are taking very radically different approach. Module Federation is all about how do you scale your application by creating these leaf nodes within the application graph that can still share state, share JavaScript, share modules within the overall federation. That's why it's called Module Federation, because you have modules, JavaScript modules that know how to collaborate and reuse each other and still be somewhat independent and in the leaves. But Fragments take the very opposite approach. And that's on purpose. The reason why we take a very different approach is that one thing that we realized is that no matter if it's Module Federation or, there have been other approaches to scaling applications, and ultimately where these approaches fall apart is that you end up coupling fates of individual teams in some point in the application lifecycle development. So if you just have monolithic application, the fates of teams contributing to this monolith are tied from the get-go. What I mean by that is that everybody succeeds only if everybody succeeds. If one person fails, it can cause a failure that is catastrophic and impacts everybody. So the success of the individual team is coupled with everybody else. And with Module Federation, this situation is much better because you do decouple the fates of teams to some degree, but it's only partial. And what we see, and when we talk to different people building micro-frontends, even at Cloudflare, we have first-hand experience using Module Federation. What we see is that it's just kicking the bucket down the street. Like, you are deferring the problem because with Module Federation, you still share state, you still have shared dependencies. And once you need to update these in some, and you will, because these applications, grow, you need to update React, Angular, whatever you have. You need to change your Redux store, which typically can be a shared dependency. And as soon as you need to do that, now you're back to the big coordination and company-wide coordination problem. And you either get it right or everybody fails. So you're back to square one where the fates are coupled is just deferred a little bit. So with WebFragments, we take the approach where we actually radically minimize a shared state and share dependencies. Every single micro-frontend, this miniature application that is part of the larger application, is completely independent, is able to run by itself. You can, in local development, you don't need any dependencies. You just spin up your application in Vue, React, whatever you have, Angular, and you can develop it locally. You deploy it to, just like you would, a standalone application somewhere. And now WebFragments allow you to compose that deployed application into a larger application in a way that the user cannot tell that they're interacting with multiple applications, but the developer can, because they can iterate on this small piece without having to worry about, oh, who's going to update React next week? They control their own dependencies. They control their own state. They control all of this stuff. But they are still able to participate in this larger application and create cohesive user experience with minimal state sharing. We do allow some state sharing because you want fragments to be able to communicate with each other. But the guiding principle is that the more stuff that is shared, the tighter the coupling, and the tighter the coupling, the more fate sharing there is, which is what we are trying to reduce.
Interesting. But how do you solve the problem with, you don't want, let's say you have 100 fragments or micro-frontends on the same page. You don't want to load React 100 times, right? You want just one React bundle.
Yeah. So
how are you solving it?
That's excellent point. Like, we are very performance sensitive. Nobody wants to download lots of JavaScript. The current situation with or without web fragments on the web is not great. We think we can help with what we are doing. But ultimately, the solution is that one of the things that are shared between fragments is network cache. So if you are able to make a request that can be CDN-like, you don't need to actually use a CDN, but it's a URL that is immutable, that is shared across fragments, and that's where you pull your React. Now, if everybody's using the same version of React, you just download it once. But the critical piece is that you download it once, but you initialize React multiple times, once for each fragment. And this means that if there's an internal state within React, which there is, it cannot collide with internal state of this other instance of React that is dedicated to it. So you still get the benefits of like complete isolation and independence, but you are able to amortize the cost of the network connection and download, because if everybody's using the same version, you just need to download once.
Okay.
Yeah, I think, sorry.
Go ahead, Natalia. No, say.
I just wanted to mention that that's one of the promises of any microarchitecture, that you have independence, team independence, you have tech independence, you have decisions, architectural decisions independence. And we have failed until now to deliver on that promise, right? And what we're trying to do is, and we like to think about this, we recently came up with this idea, actually. What we're building is kind of like Docker, but on the browser, right? So we are fully encapsulating a context of execution for JavaScript. And at the same time, we're encapsulating the DOM, but in a way that it still is one single document. And we're going to explain you a little bit how we do this, but we still deliver on that promise of full independence and not sharing the fate between teams and between applications. To some extent.
Makes sense. What attracted you, Natalia, to this project in the first place?
First of all, like I mentioned, I had been building in the space of micro-frontends for a very long time. And I'm talking about enterprise mission-critical applications that need to be somewhat decoupled and live their own fate, like we said. And that led me to experiment with multiple technologies, including module federation. Back in the day, it wasn't even released. I think Webpack 5 wasn't even released when I was already experimenting with module federation. And for some time, I could achieve what I was intending to, but it came to a point when I started finding some limitations. And this technology in particular, WebFragments, solves many of those problems because it's vendor agnostic, it's technology agnostic. And like we said, it allows you to fully encapsulate your code. And with all that in mind, I started participating of some brainstorming sessions with Igor. We were discussing implications of using technology like iframes. Iframes have been there for a very long time, and the objective of using or the intention or the way iframes were designed were not to perhaps use it in this way. It's a technology that's been there for a very long time, but it's also a standard. And that's another thing that really motivated me to contribute to WebFragments, that the underlying layers and the engine underneath WebFragments is the web platform. And I am a huge proponent of using standards and the minimum layer of abstraction possible, because that's future-proof. That's something that everyone has access to, and that requires minimum maintenance, as opposed to a framework that may need to be maintained in and out of itself. You don't have to worry about maintaining the iframe code, right? You don't have to worry about dealing with the browser cache. All that is given to you. So yeah, that's
Do you want to talk about why iframes didn't work out?
Well, iframes didn't work out fully, because while you have some pros, some benefits of using iframes, you may get your code encapsulated at some point. You also face accessibility issues, UX and UI issues. And those are mitigated by the fact that the only thing that we are running today in the web fragment context inside of an iframe is JavaScript, not rendering the DOM itself. So we are not constrained or limited by those cons of the iframe in general.
Earlier, Natalia made this comment about Docker and
containerization, right?
Containerization. And I think it's important to come back to it, because that gives us the right mental framework to think about how we approach it. Imagine the world before Docker and before containers. What did you do? You had probably some virtual host, or you had your physical server, and you had 5 applications that you need to run. You would go, you would log in, you would either FTP, or you would install packages, or whatever you would do, and you would somehow spin up these 5 services in the same operating system. And that worked. Like we ran operations for like that for a very long time. But at some point, people realized that, oh, this is actually not very good, because sometimes we need to update the shared dependencies. Like I need to update this system library, or we need to do this operating system maintenance, or other things, or we might need to write into a file system, and the applications are trying to write into the same path and collide. And if you think about it, like, this is exactly the same problems we had, but on the client side. You just need to translate, instead of talking about system libraries, you need to talk about like my framework dependency, or some component library that everybody's using. Instead of talking about writing into the same path on the file system, you can think about a global variable that everybody's trying to use. And, the problems translate. And in many ways, many of the problems that we have on the front end have already been solved on the server side many years ago, or some years ago. And if we could learn from that and apply the same solutions but translate them so they're appropriate to the front end, we could solve these problems in a similar way. And this is where Docker came along. Docker allowed you to create containers. You could put in 5 applications, you can create 5 containers. Each application lives in a second container. You can still deploy it on one physical host. Applications, you build them in a standalone mode. They don't know about each other, but in production, they're actually deployed on one physical node, physical host, without knowing that they are sharing the same CPU and memory with 5 other applications. To them, it looks like they are on their own. They own the full computer, and everything. They own the world. But fragments do the same, but for front end. And the way it works is that we create this illusion in the browser that an application that was developed as a standalone application is owning the top frame of the window, owns owns global variables, owns module loader, owns everything. But it's really just an illusion. In fact, what is happening is that this application is running in a container, in quotes, that we created. We call it reframed container. We call it reframe container because it actually uses iframes under the hood. But it uses iframes in a way that you probably haven't seen used before. We use iframes to solve the problem of JavaScript collisions. Each application, we need to create JavaScript context, new JavaScript context for this application. And there isn't an API in the browser that allows you to just say, V8, give me a new JavaScript context and load this application into it. What you can do, however, indirectly is you can create an iframe, and with a new iframe, the browser will create JavaScript context for you. And then you can use this JavaScript context to dedicate it to the application, to the running. And you can do this multiple times, and you can run 5 applications at the same time or swap them within a single SPA. And this allows you to load these applications in a completely independent way. And solves the problem of JavaScript collisions. However, if you just use iframes as they are, you would have a second problem, which is the UI would render within the iframe, and that iframe would be nested in this more complex document, which means, first of all, like you can't really start rendering anything until if you have an SPA, your SPA needs to bootstrap, it needs to create the iframe element, and the iframe needs to make a request. And only then the browser can start bootstrapping the application. And that delays everything. It creates this cascading waterfall effect. It's not good for performance. Additionally, you have a problem with accessibility, because accessibility within iframes is not, it's possible, but it's not trivial. It's extra maintenance. You have to take extra steps to make it work. And we get it wrong all the time. So if we could remove that obstacle, that would be great. And lastly, it limits you in what you can render, because with iframes, you're limited to the rectangle of the iframe. So if you want to create a modal dialog that might need to overtake the entire viewport, you just can't. It's not possible with iframes. So what WebFragments do with this technology we call reframing is you still get the JavaScript context of the iframe, but we don't use the DOM of the iframe for any rendering. Instead, what we do is we use the main document to render the UI of the application running in iframe. I'll say it again. So application runs in the iframe, but any kind of DOM operations don't happen in the iframe. They happen in the main document. Now, if you just did this without any other precautions, you would have other problem with collisions, which is your IDs, DOM IDs, could collide, your CSS can collide, and there are other things that could collide. So we use shadow DOM to create a boundary, isolation boundary for each fragment. So each fragment uses iframes to isolate JavaScript, then uses shadow DOM to isolate the DOM of this fragment. And this gives us a full encapsulation both on the visual side and CSS side and DOM side, as well as on the JavaScript side. How is this possible? I'm happy to go into the details if you want. We call it reframing. It's a little bit of a magic that we developed. But the cool thing is that even though this is really virtualization that we are providing, just like Docker virtualizes operating system calls, we virtualize DOM operations through reframing in WebFragments. And usually when people hear virtualization and emulation or stuff like that, they get worried about performance. We do it in a way where there's almost immeasurable, like you barely can measure any overhead. Like you would have to know what exactly to measure to be able to show like, oh, this is slower. But for most applications, like there's no degradation of performance in spite of this virtualization.
We have a very nice Sierpinski demo where we show this massive triangle rendering in the endpoint itself and in the application that's requesting that endpoint, and the performance is almost 1-to-1.
Oh, that's impressive.
So yes, and what I wanted to add is because these applications are rendering in the boundary of a shadow DOM, but inside of the same document, they of course have access to APIs as if they were part of the same document. For example, the history API or the what's the other one?
Navigation in the browser.
Yes,
right?
No, but it's a different name.
Sorry, I was trying to pull up the
history,
the triangle
and
demo. History, location.
Location. I don't know why it was in my mind. Localization. Yes. History, location, all these APIs are shared, and then you can use the regular UI of the browser to navigate back, navigate forward. And if you don't want that, if your fragment has its own routing inside of itself, you can also control that with WebFragments. So you may want to have the navigation be replicated in the host. For example, imagine you have a catalog and you want to visit each detail for a product, and you want that reflected in the URL of the browser. But maybe you have a different application, a different fragment, like, I don't know, a shopping cart, where once you check out, you want to display some sort of hint of state, but it doesn't necessarily need to reflect in the URL in the browser. You can do both. This is what we call linked and well, did we decide how we're going to be calling them in the
Bound
end?
and unbound.
Bound and unbound fragments. We were debating if it's the right nomenclature for this functionality.
Yeah. In the meantime, I did pull up the demo. I think it's going to be useful to just visualize some of this, and we can actually you can show some of this because we've been talking a lot, but I think demo is always worth quite a lot. So this is the Sierpinski triangle demo that I think the React team popularized. This is a solid implementation done by Ryan Carniato. The nice thing about WebFragments is that you can use it with any framework. And somebody actually asked me like, oh, is WebFragments a meta framework? I'm like, well, not quite, because Remix and React Router 7 and QuickCity, those are meta frameworks. WebFragments allows those to run inside. So it's really a meta framework if you want to be really pedantic. But the point is, this is a solid demo running as a web fragment, and this is the same demo running in a standalone mode without all of the virtualization, and you just can't tell the difference. It's exactly the same performance. So when we have big applications that we build at this point, and in terms of like DOM operations, we don't see a difference in performance.
Intriguing. And does it work with, you said you're framework agnostic? Can you do like different rendering strategies, like server-side rendering? Whoops.
Yes, exactly. And in fact, it was one of the motivations for doing, like, some of the core principles and design decisions were done around how can this enable people that are currently building a monolithic SPA or module federation SPA. How could they incrementally migrate over to server-side rendered world? Because we do strongly believe that you can achieve better user experience with server-side rendering on the web, but going from a big SPA to a server-side rendered application, it's just too hard, because often it means full rewrite of the application, which nobody wants to fund because it's big risk, it takes a long time. But if you could do it incrementally, if you could just say that, oh, we're just going to take one piece of the application and rewrite it with server-side rendering, see how it goes. If it goes well, then we pick another valuable part of our existing application and rewrite it with server-side rendering. Then you could, over time, rebuild the application with completely different stack, maybe different framework, different architecture, and maybe even different hosting provider. Because one of the things that we talk about is we're trying to be completely vendor agnostic. So we don't have any ties to build tools. So we don't tell you have to use Webpack or Webpack or roll down or something. You can use whatever you want. You can use whichever hosting provider you want. I'm at Cloudflare. We're using it with Cloudflare, and it's really working really well. But if you already are committed to another provider, you can use WebFragments with that. That's fine. You can even use WebFragments to actually incrementally migrate from one provider to another, which is another really cool thing, because by separating these things and hosting them independently, you can do that.
I don't know
Ali,
if
are you
you're
going to show some demos?
Yeah, well, this is a demo, like the host application is a React application that is running on Azure in a container. And then we have these two web fragments. This is a Next.js application that is a catalog, like the example I was describing before. And you see here, there is a shadow root, and we have prefixed each one of the main elements. So this is another it's an implementation detail, but it also prevents collisions and it prevents to have duplications in HTML elements. So it's valid HTML as well. And here we can see we have the fragment that pertains to the cart, and it's a quick fragment. So basically, if we scroll all the way down, we can see here the iframes that we were mentioning before. So the JavaScript is actually running here, whereas the DOM has been rendered over here. And I want to show you a very, very neat thing, and it's this eager rendering of the application that now Igor is going to explain. You see how the application, the host, takes a while because it's client-side, so it has to render itself. And the catalog renders immediately. It's not only that it renders immediately, it's interactive immediately. And this is because it's inlined in the HTML in the server side. Igor, you want to talk about piercing?
Sure. So as I mentioned, one of the motivations is to help people get to server-side rendering. But what is server-side rendering good for if the shell of the application is client-side rendered? Because that would then typically mean that you need to bootstrap the client-side rendered application, and once you build out enough of the DOM, enough of the UI, that's when you can do server-side rendering to inline a part of the UI. And that defeats the purpose of server-side rendering, because the whole reason why we want to do server-side rendering is so that we don't have this big pause between when the user initiates the navigation and when something shows up on the screen. We want the initial rendering to be as fast as possible. We want to show something very quickly, and not just show. I mean, we actually want to make it interactive, as Natalia mentioned. And this is why we developed a feature within WebFragments we call piercing, fragment piercing. And the reason why we call it piercing is because if you think about it, we need to be able to pierce server-side rendered content into a client-side rendered content in a way that allows you to show the server-side rendered content before the client-side rendered content even exists, which is interesting because, like, how do you render into something that doesn't exist yet? But that's what piercing does. It's another part of magic that we developed for WebFragments. I'm happy to talk about the details on how it works, but it does work, and we use it in production. And it gives you this effect where if you have an application that is taking a long time to load, then you can use piercing to actually show the UI much faster. The best demo, the thing that actually like inspired me to develop this was my frustration with the Cloudflare dashboard and the login experience. Because in order to see a logins form that literally has your username and password and 2 buttons, you need to download, I think, 6 megabytes of compressed resources, and it takes, like, depending on the connection, it can take like 10, 15 seconds. So I was thinking, like, okay, if I just wanted to just take this form out and render it as fast as possible, how could I do it? And that's how piercing was developed. But now we use it throughout for any kind of UI. And you can show the demo. Dalia.
Yeah, so what I was demonstrating here is I mentioned before that the cart is a quick application, so it obviously has some objects, like, for example, the quick events that you can access over here. But if I go to the catalog, which I mentioned, it's a Next.js application, obviously the quick events are not part of it. And that means that things like memory leaks or whatever is happening in that context is not affecting the other fragment, right? And if we would remove that fragment entirely from the DOM, then everything is gone.
That's pretty cool. So how do the web frameworks, because I see now you can add to cart and probably it appears into your cart. So how do they communicate with each other, the different fragments?
Yeah, that's
Or are you
correct.
pushing state in each of them and you keep it in the shell?
Pushing state, and we're using also a standard. We're using the broadcast channel API. So yes,
Okay.
exactly. So if I if I go back to products here, let's empty the cart. What I don't have running is a checkout server, so I cannot do a checkout, but I can add anything to cart and it's working. And if I say, okay, the Angular developer T, I want another one. So you see that it's increasing. I remove it. And then if I would be proceeding to checkout, then it would just work. And you cannot tell as an end user that you are actually interacting with two different applications in two different technology stacks and actually deployed to two different or three different vendors. That's something that you shouldn't know anyway. What it's doing, it's posting. This application is posting to a channel that this one is listening to as well, right?
Interesting. So if you can deploy it to different vendors, do you have any limitations with like cores or whatever that can happen when you're making requests?
Excellent question. We don't have course issues because the entire deployment lives on a single origin.
Okay.
So there's only one domain that is public facing to the browser. And all of the fragments are making a request to a single origin. What we do have is on the server side, we have an Edge middleware or middleware. It can be either Node.js middleware or it can be Cloudflare middleware or any kind of. All of the servers at this point have middlewares. So you just need to, we have a vendor agnostic middleware that you can insert into your pipeline. And what that middleware does is it inspects all of the requests that are coming from the browser and knows how to route them to different endpoints. So it can, the middleware can identify, oh, this is a request coming from my shopping cart fragment. And I know that the shopping cart fragment is deployed on this, I don't know, Amazon Lambda or Cloudflare Worker or Azure, whatever container. And it knows what the location of that, and it will just send the request to that endpoint. And what it will receive back is a response that then relays back to the browser. So in this way, we're able to have a single origin. We don't have to deal with coarse policies at all. All of the requests are making it to gateway, to the middleware. And the middleware then routes the requests to all of the right places that can be cross-vendor or cross stack. You can even, like, the crazy thing about it is that you can even have a PHP application that you are incorporating into you can have MPAs that you're mixing with SPAs. Like, this is like completely agnostic of languages, of vendors, of tooling, because fundamentally what we are doing is we're just using web APIs in a way that have not been used before. And we have implemented this possibility just using web APIs. So like, I really like the interface to the application is any browser API that you can think of. That's what we expose. We like WebFragments don't really, there's a little bit of configuration. That's the only API surface, but there isn't like, you don't call like WebFragments do something. There's no such a thing. You only have window dot something, window dot console or document dot, like all of the DOM APIs. That's your API service that you are building your application against. And what we do is we either just let you execute that call the way it should be, or we do a little bit of manipulation to retarget it to this place in the shadow root of the main document, so that it executes in the main document and DOM operation executes in the main document and not in the iframe.
That's amazing. I feel like it's such a big project. And, with micro-frontends, you always hear like, they're not mature enough, like they're not proven. How long have you been working on it? What's the lifetime of WebFragments so far?
Yeah, I started poking around and building the first demos before I joined Cloudflare. So that was in 2021. And then I've been working on it on and off at Cloudflare as this like research project, hobby project. We published some research blog posts about some of our findings and incremental progress. And last year, we actually committed to using this technology for our own use. And we're rebuilding our mission critical dashboard that all of our customers use with this technology. And that project has been going on for a year now. And we're just building more and more ambitious stuff with it.
Do you know of anyone else using it right now in their production?
We are talking to several companies. I'm not sure if we can name them, but there are people that are poking around. They're either people already using it, or they are running pilots and determining whether this is the right fit for us. But we're working with companies, and usually like it's big companies that need this stuff. You wouldn't attract a hobby developer or a small startup. Like, this is not a technology for small startup. This is the technology for banks, for airline companies, for insurance companies, for like these big manufacturing companies that have large enterprise front ends and need to modernize them. And those are the kind of companies that are
interesting.
And I'm personally experimenting with WebFragments internally at Microsoft in products I own with great results. Like Igor said, the main use cases is application modernization, incrementally move to a new technology. So big migrations that take you to, being sort of productionable in a short amount of time without, again, sharing the fate and impacting the rest of your application performance.
So how do you recommend like developers start with it? Exactly this, like migrating to WebFragments from their monolithic legacy application.
But the easiest is to just you can take a look at a repository. All of our code is open source. It's on GitHub under the Fragments organization, and we can also share some links with you, so you can add them to footnotes to the show.
Please.
But we have some demos. People can play with them. We're making the technology more and more accessible. Like, we know that documentation needs some work, and we're actually preparing a workshop for later this year. Once we are ready, then there's going to be like a tutorial that will walk you step by step with onboarding on this. But it's really, we think that onboarding is actually quite easy. Essentially, all you need to do is have ability to insert a middleware in front of your existing front end and load JavaScript into your front end. And once you do that, then you can develop a completely independent application, or we have some demo applications that we developed, and you can incorporate into your application with that. So we know that we are still pre 1.0. Documentation is something that we do need to work on, and we have Natalia did a great job building our Fragments to Dev website. But I think once we have the tutorial, onboarding is going to be much easier. In the meantime, you can look at existing examples. We'll share links and kind of like reverse engineer how things work. But yeah, playing is the best way. Playing is the best way. Get your hands dirty and let us know how that goes.
I will. I'm super interested. Is there like a steep learning curve, or you think it's very easy to?
The initial setup is like 5 steps or 4 steps, and once you have the initial setup done, then you're just developing against the browser. Like, you can create new application, brand new application of any kind, register it with your WebFragments gateway, and you'll see it running. I can give you an example of how we use this at Cloudflare, and a lot of this is still work in progress, so hopefully nothing will crash. One of the things we've done at Cloudflare is we have this massive dashboard that we developed over the many years. Cloudflare is celebrating 15 years this week. Over the last, I think, 8 years, people have developed this SPA that is the current dashboard, and it's a client-side React application. It's too big for anybody to fully understand. It's contributed to by everybody at the company. There's so much tech that it's not even funny. But at the same time, it's mission critical. Like, this is what our customers use to interact with Cloudflare, and when it goes down, it's a big problem. But if you have all these people contributing to a single code base that is very fragile, it goes down more often than we would like. So this is one of the reasons why we determined that we actually do need to figure out how to decouple fates of individual teams. And if somebody introduces something that is problematic, we want the blast radius of that error, of that mistake, to be encapsulated within a container of some kind. And that's how WebFragments solve this problem. So to quickly show you, like, what you're looking at is this is the dashboard. It's a client-side rendered application. If I reload it, I'm on a 2 gig internet connection, and it still takes a few seconds to reload. If you are on a normal connection, it can take 10 to 20 seconds to fully initialize and load, because there's just so much stuff that has been downloaded and lots of various issues that individually can be solved, but there's just so many of them, and more are coming as more people are developing and adding things to the application, that it's very difficult to stop the flooding of stop the bleeding of in this application, unless you find a way to decouple the fates of the individual teams. So the thing I wanted to show you is that what we did is we actually started very small. We started with this application where this is the user profile settings page. We completely rewrote it, and we rewrote it with a very different stack. So the shell of this application is client-side rendered React. It's, I think, React 18 and React Router 6. But inside here, what you're looking at is a brand new application. Original was Remix, now it's React Router 7. We're also experimenting with Quick. But it's a completely brand new application that was developed. It was developed independently of the rest of the dash. It looks the same, so visually you cannot really tell the difference. We are sharing some CSS tokens so that the colors and stuff matches between the legacy application and new. But we deployed it at a completely different endpoint, and this is the production application. I can interact with it, and if I change things here, let's say I check this checkbox and come here, you see it's checked. If I uncheck it, like this is the real application. It's unchecked now because this application talks to actual backend, and the backend is where the state is stored. And this endpoint is what our micro-frontend is talking to render this UI, to make all of the asset requests, to fetch all the assets, and to make all of the data requests as well. But as a user, you can't tell that you're looking at two applications now. If you look under the hood, you'll see that we have WebFragment here. This rectangle that is highlighted is a WebFragment that is in the feather blue that I mentioned. And then we have DOM that looks like full HTML. We have HTML head, body, and all of that stuff. We have some scripts, which might be confusing because you might be like, oh my gosh, they're executing scripts in the main window. These scripts are here because React expects them, but they're not actually, they're neutralized, and they don't execute here. They are here just because if we remove these scripts, all of the indices of DOM nodes would be off, and React hydration would fail because it expects a certain order of nodes. So we do put these script nodes. They look like real nodes. They don't actually execute. And there's another magic trick that we do to neutralize these script tags. But down here, there's this iframe. And this iframe, if you unroll it, contains all of the script tags and link preloads tags for all the scripts in this fragment. So this is where we actually download and execute the scripts. But then the DOM operations happen in the shadow root above mentioned. And the cool thing is that you can use existing dev tooling to debug this application, because dev tooling already allows you to switch between frames. So you can switch between top frame, which is the legacy application. Here, if you do build, this will show you what is the build information from the legacy application. But if I go to my web fragment and I try to do build, I don't think we expose that information. But instead, there's going to be some like React Router version. Let's see, 7H2. I wonder if the same will work here. Oh, okay, it doesn't exist in the top frame. So they just added it in version 7. So the point is that you can use existing dev tooling to debug this kind of application. There's nothing too foreign or magical about it when it comes to like troubleshooting and debugging issues. Your dev tools apply just fine. And you know how we talked about the piercing? Let's see. So if I reload, you see that we show you the fragment instantly. And then in the background, you see there's a skeleton that we had to put in, and we're waiting for the legacy application to start. And that's the piercing feature that we talked about. So if you have an eShop, for example, or you have other some kind of like UI real estate that is very latency sensitive, and you're suffering because you made the choice of building with SPAs, and SPAs take too long to start, you can take that one rectangle or one piece of the UI, rebuild it with WebFragments using some server-side rendering technology of your choice, and you can actually show it to the users very quickly, just like we can.
That's really cool. So what's next for WebFragments? What do you want to build more?
We're maturing the technology. We're building bigger and bigger applications. I'm going to try to show you this. Let's see if it works. So one of the interesting things that we're doing at Cloudflare now is, which is really pushing the boundaries of WebFragments, is we actually have two dashboards, two SPAs that have been built. And the second one was started like 5 years ago. There's a whole team of engineers. It has like 300 routes. It's a big application. Our main dashboard is even bigger than that, but I think it's the main dashboard is 3 times bigger than this one, but this one already has 300 routes. So it's big applications. So with WebFragments, we're exploring, could we actually strip this? And the annoying thing is that if you navigate between them, they are on 2 different origins. And because there are 2 SPAs, going from one to the other, which is a very common user journey, is very painful. So we're trying to think like, could we actually combine these 2 dashboards into one and use WebFragments for that? So we have an experiment where we stripped the header, the navigation, and the footer, and took just the content of this second dashboard, the Zero Trust dashboard, put it into the container, and put that container into the legacy first dashboard. And what that looks like is like this. Like you can't tell the difference, right? If you look at the content, that's the only thing that was preserved from the second dashboard. But now we have ability to like have the second dashboard nested in the first dashboard and navigate. Oops, I'm actually clicking on the wrong one here. This is the second one. But now I can go to any other route within the first dashboard, and it feels like a single application, even though it's really 2 massive SPAs that have been merged together using this virtualization technology.
And can you have like WebFragments inside WebFragments that load inside the main
Excellent
application?
question. Almost.
Not
Almost. Not yet. So we have, yes, we will need it. And this is why we're not 1.0, because there are still like some features, advanced features that we want to develop that are not finished. We will need it for some work we're doing at Cloudflare, and that is planned. It's currently not fully implemented. So there's still some implementation gaps that need to be done. But yeah, fragment nesting is a thing. Having multiple fragments on the same page at the same time is also something that we support. We have so many ideas. Just the other day, Natalia and I were talking about, with WebFragments, we could actually, for the first time, do out of order streaming, which is like one of the holy grails of SSR at the fragment level, because it's very difficult to do it within an application. Like, you really need so many things to opt in and just work for out of order streaming. But at the fragment level, we could actually have 2 fragments that are loading in parallel, and they are streamed at the same time. And that makes out of order streaming possible. We have lots of ideas. It's just a matter of like, these technologies, we are trying to make it as transparent as possible and enterprise ready. So we cannot move very quickly and just implement a lot of features at once, because nothing will work. We're also running this in production, so we need tests for everything and make sure we don't cause outages. So we're moving more slowly than I would like, but also I feel like we're making incremental progress towards like something that has never been done before. And many of the things that we already achieved work in production have been proven in production and are so unique that I feel like saying that WebFragments do take a radically different approach to micro-frontends is justified.
And we have a lot of stuff in the roadmap, and we have some progress on certain things like the native broadcast channel implementation. And we have a design for asset sharing, because this is a question we get over and over and over. So we want to solve that problem as well. So yes, we have a lot of things in the pipeline, and yeah, working towards the stable release, hopefully soon.
Do you
Yeah,
have
I would like to get 1. I would like to get 1.0 out before the end of the year. That's our like internal goal. See how things go. We feel like we're pretty close. The fact that we are able to run this stuff in production at Cloudflare at large scale gives us a lot of confidence. When we talk to customers, one thing that we hear that is holding them back from adopting WebFragments is that we are not 1.0. So there's this like psychological barrier. So we don't want to rush it, but also we don't want to delay it unnecessarily. So 1.0 by the end of the year.
That's good to hear. What about contributors? Besides you two, do you have a full team? Is Cloudflare actively working on it, or is only open source contributors? How do you handle that?
It's open source. We did receive a few contributions from various teams that were either poking around or actively using WebFragments. But mostly right now, it's just me and Natalia. As Cloudflare is getting more and more involved in using this, I'm trying to bring more people from Cloudflare to help out because there's a lot of work that needs to be done. But also, I do want more people to understand how this works because it's not the code that you read every day. It's not a whole lot of code to do this, but it's not a everyday code that you're exposed to. So it does take some time for people to start for it to click. Like obviously, like if I have this issue, then this is how I approach it. And for that, we need to grow the contributor base.
And if someone wants to contribute and help out, how can they start? What your recommendations?
So
4 can open up a request.
well, okay. One thing I've been talking about forever, and I committed to doing this week, and it's Friday, so I still have 2 more days. Discord. We need a Discord because there's more and more people that are interested in talking and helping each other and contributing, and we need a place to talk. So we're gonna set up a Discord. So by the time this air shows, there's gonna be Discord channel, Discord server out there that you can come and say hi. And if you're inclined to contribute, we've been doing a pretty good job of filing issues and explaining what needs to be done. So we can pick an issue that would be good first time contributor issue. And then just we can coordinate the development on Discord. All of this is open source. Natalia works at Microsoft. I'm at Cloudflare. So there's very little that happens on WebFragments that is happening in like behind the corporate firewalls. Mostly it's just the testing and validation that happens.
Amazing. One more question. I think we're right on time with this episode. This is one personal that I ask for everyone that comes to the podcast. Can you recommend a favorite book? Usually a technical and non-technical book with some of my readers.
Just one? Oh my gosh.
As many as you want. You can give me 5 each. I really like to read, and I'm creating lists.
Non-technical, Finding Ultra. I have been mentioning that book to somebody recently. It's a book
Finding
about this
Ultra?
guy who, Finding Ultra. It's I like doing triathlons, and this book is about a guy who goes through midlife crisis and decides that triathlons are not hard enough. So he comes up with this challenge, or agrees to do this challenge, where he does 5 Ironmans on 5 islands of Hawaii, one day after another. And the book is about his journey and how he did it. And it's very interesting.
I'm gonna read that. I love have you read the Born to Run one about running?
Yeah, Caballo Bianco. Yeah,
that's really good.
I still run barefoot.
Really?
Yeah. Technical one. Natalia, you go. I'm gonna think about this one a little bit.
I'm going to show the books. Actually, you should read this one.
Oh yes.
This is for women.
Likeable Badass.
How women get the success they deserve. And this is actually a present from Igor. And this is what I'm reading right now, but it's in Spanish. And I can say it's technical. It's the infinite pleasure of math. And it's all about, and I'm reading this book because I have a boy, 11 years old, and I have to sit down and make him like maths. because it's not his favorite subject. And it has a lot of nice examples of why we need maths on our daily lives. I really like it. I'm enjoying it a lot. This is what I'm reading right now.
That's very cool.
Okay. I have a technical book, but probably not the kind of technical book that you expected. Now I'm actually thinking of two technical books.
I'm thinking about another technical book, but yeah.
Principles
It's
for
called
Good
10
Design.
Principles of Good Design by Dieter Rams. Dieter Rams was a designer, industrial designer, actually. He would design furniture and tea kettles and stuff. And he wrote down what it takes to build good design and how to design products. So like many of the principles that he talks about in how to think about a blow dryer, you can apply them to software as well. And I often find that the best advice for software engineering, I find somewhere else than in software engineering, because just like with the client side and server side, many of these problems that we have been already solved in other domains, and learning from those can help us come up with, just rely on a lot of knowledge that was already gathered from other spaces.
I'm going to check it out. What was your second, Natalia? What were you thinking about?
There is this book about structures also that is
Yes,
very interesting.
that was
and
my second one. That was my second one.
Wow, you are like
Actually,
connected.
I like it so much that I bought it for Natalia because
Yes.
What's
So
it
it's
called?
called Structures or Why Things Don't Fall Down. Yes, fall down. And that's an amazing book. And you can also apply the learnings to many, many things.
Yeah.
So
it's all about
it's
beams and
it's
building
engineering
bridges.
and architect. Yes, it's engineering and architecture. But then again, you start understanding that the foundation of things, even in software engineering, are the same for everything.
Amazing.
And in life. Yeah.
Thank you so much for this many recommendations. I'm going to order them right after this call. I have a lot to read up on. So thank you for joining. It was such a good talk. I owe Natalia a beer for doing this and bringing you on, Igor. Thank you so much. I think
Of course, it was a pleasure. Thanks for having us.
Cool.
We'll meet in Barcelona sometime.
Yes.
Maybe we can do this live.
Let's do it.
Okay.
Have a nice
weekend.
Have a nice weekend.
You too.
Thanks.
Bye-bye.
See you. Bye-bye.